Hello, my name is Guido Loris from Software AG. I'm going to present you now the demo of a service fleet optimization system that we developed together with TomTom Work. This demonstration is showing a little story of some football fans that are going to watch the Football World Cup Final 2010 between Germany and Spain. And then the worst thing you could imagine happens, the TV breaks down. So the guys are totally confused and disappointed, and they call into their cable provider if the cable provider might be able to fix the problem. So in our solution, the call center agent can now take data from the connected customer relationship management system and submit a new order to the service fleet that is sent to the customer. What you can see here now is the status of the process that has been initiated with that system. We have the ARIS view of that process along with the web methods view of that process. So you can see that both processes are showing, that both models are showing the same process, but with different perspectives. There's a business user perspective and the technical perspective, but it's the same process. You see now that the process is now waiting for an approval by the driver. How does it work? The system is now using a TomTom Work network to connect the call center agent with the driver. So the request is sent via this network to the driver onto the TomTom system that the driver has in his car. What you see here on the TomTom device is that the driver sees a tiny letter which shows the order that has been sent by the call center and can accept that order by just using the TomTom device. This now is sent back to the process instance that has been initiated, and as you can see here, the process now goes on because of that message. So that shows that our process engine is really driving that process, which gives you a lot of flexibility if you, for instance, want to change the process, or as shown in that situation here, if there is a problem occurring. So in this situation here, you see that the driver has the problem that the car breaks down. So compared to other systems, this is a very important USP of our system, because the exception handling that you can introduce with intelligent processes within the web method suite gives you more flexibility to work with the orders in your fleet. As you can see here, the driver is able to send back the problem report to the call center by just using the TomTom device. This saves a lot of communication costs and also saves on human interaction. So there is no human interaction required to let the process go on and let the order still be fulfilled. How does it work? You can see now here that the process is now in an escalation mode, and automatically, with the intelligence that has been defined in the model, can reassign the order to another driver. So this driver now has the same letter on the TomTom device as the driver before, and can take over this order. So the driver is now automatically dispatched to the customer and navigated via the TomTom navigation system. The nice thing here is that you can not only use that telematics kind of thing with the system, it's also possible to connect all the data that you can collect along with the process with your backend systems. For instance, you can track the work hours of the driver by connecting it to a HR system, or you can have all kind of data that you can analyze later on. So let's see how the little story that we're telling here evolves. So the driver arrives, and the arrival of that driver, he can report using the TomTom device. So I will do that by just telling the TomTom, via the TomTom device, I arrived at that destination. So by that, the process will go into the next step, and we'll now go on with tracking how long does the driver now need to fix the problem. This is an important data within the service fleet to make sure that the optimal way of dispatching and fulfilling orders is managed with the process engine. So again, let's assume that the driver now fixed the problem, or at least started to fix the problem. He could say, okay, I started to work on this problem, and assuming he fixed the problem, he now can also say, I found the reason for the problem and I finished the order. Looking at the movie, you see that these guys are still a bit bored, but as the process is going along, you see that the disturbance is gone and the guys are now able to watch the World Cup final and are very happy. So now coming to the last part of our demonstration is to show what is really the effect and the benefit of such a solution. We show that with the so-called mesh zone component, which is an IDS shared product. And this is showing now typical data that you can achieve and typical benefits that you can achieve with such a solution. Using IDS shared product RS mesh zone, we are now able to monitor and visualize the benefits from that solution. So here you can see how, since the introduction of that system and that solution, the carbon footprint within your fleet has dramatically decreased. So you can see here that from this point in time, end of 2008 till today, the carbon emission has been reduced by more than 200,000 kilogram per quarter, which is 800,000 kilogram a year, which is achieved by the optimized dispatching of resources through the combination of TomTom work and web methods. You can see that the kilometers that has been spent in deadheads, which mean that the driver was not able to fulfill the order because of some problems, or maybe the customer is not available, has also been reduced by more than 600,000 kilometers. Another nice effect, of course, is that the utilization within your fleet increases because of less deadheads and more flexible ways of dispatching resources. In this case, we have been able to increase it by 7%, which can result in a decrease of the numbers in cars that you need at all in your fleet, and which is another cost-saving potential. Looking at these numbers here, you can see that, of course, the petrol consumption significantly increased with that system. And another very nice cost driver that can be killed or reduced is the hours that you have to spend on the cell phone, and the mobile phone bills are much better than before. Having paperless processes in place, like we showed in the demonstration, you can dramatically save on paper costs and paper that you waste because of the processes. Because of the intelligence that we have in the processes and web methods, as well as in the data that TomTom Work uses for the navigation, we are able to reduce the hours that cars spend in traffic jams significantly. You can see here that we reduce the hours by 50%, and this is especially the case in the morning times and in the evening times where there are a lot of traffic jams. The last thing I would like to demonstrate is the driving behavior and how you can influence that. The system is able to categorize drivers within your fleet according to their driving behavior. So for instance, you can see here the aggressive drivers, and you can see how they have been reduced. How is that possible? So connecting these data with your backend systems, like the HR systems, you could create a bonus program that incentivizes those drivers that are defensive or normal drivers. Here you see that the defensive drivers increase because of that bonus system that has been introduced in that example here. So all in all, you can see that the combination of the product from TomTom work called Web Fleet, and our web method system with intelligent systems, intelligent processes, and process excellence that also reacts intelligently on problems that occur in the fleet is something that can dramatically improve the way how your service fleet is managed. Thank you for listening.